Okay. Questions on this worksheet on a lot of the basic SOHCAHTOA, setting it up, solving for x. So first three, you're solving for a side. X is a side, of course. Whatever side you're given, whatever side you want to find, that's how you determine which trig function to use. We did have on the board, I had it erased just to clean things up for preview day yesterday. That was like our open house. But anyhow, you guys should know sine is opposite of hypotenuse, cosine adjacent of hypotenuse, tangent opposite of adjacent. Answers right there, rounds to 2 decimal places. More of the same stuff. Excuse me, I'm a little under the weather. 4, are you feeling better, Will, by the way? Okay. 4, 5, 6. Any questions on 4, 5, 6? By the way, for something number 5, we're going to talk about a way you could do 5 without a calculator. There's a special ratio that triangles of 30 and 60 degrees have. We're going to talk about that later today. Here we have to find the angles now. So to see theta, that looks like a little zero with a line through it. You have to do something called the inverse trig button. That's second, and then the button on your calculator. We'll make sure we do a quick review of that today and before the quiz tomorrow. But make sure you're aware how to do that. And by the way, you got to be in degree mode. Always, always, always. If you're not in degree mode, you will miss every single question on the quiz. You got to be in degree mode. Okay. I will show you how. It's really simple. I'll remind you, I'll put in bold caps, underline it. So make sure you're in degree mode. So you had a question?
Oh.
Yeah.
I was gonna ask how you got it to be degree mode.
Yeah, just go to mode and switch it over. Yeah, it should be self-intuitive after that. Or intuitive about yes, and then collide after that. Yes. Yes. Yes.
Right on.
Yes. Yes. In pre-calculus. Yes. Yes. And that really sucks. So you don't want that to happen.
Okay, so retake it.
Yeah, but it's like this is like many years ago when we had a different policy on retakes, and it was just and also in the AAC sometimes they don't know. I mean, you two doing the quiz in here, but like on a test, you don't want that to happen. So anyhow, what else we got going on here? Okay, any question on these? We're okay? We're good? And again, when you're trying to solve for the angle, same thing. Set it up first using the proper trig function. So if you're given opposite hypotenuse, of course, using sine, right? We're here using adjacent hypotenuse, of course, using cosine. But then to undo the trig function, where we have to do that trig function rates a -1 power. Technically, it's an inverse notation. That's what you're doing. So, okay. All right, then the clinometer. Did anyone have any trouble? They want some help or guidance? I think I may have talked about number 2. I may have set that up, or maybe I didn't. I don't know. But I don't know the actual answers. I should need to ask Mr. Davidson. But if I were to guess, I think the flagpole's somewhere around 30-ish, maybe high 20s, low 30s, maybe 67. No, just kidding. I know, right? Number 2, how far away were you guys? Would you say about?
From what?
So when we were facing the stands, the field house.
What? Oh.
I think it's supposed to be 78 or 84. I don't know. Or maybe I could be wrong. I could be wrong, actually. I could be wrong. And then for number 3, the crossbar. 1.57 feet. No, it's gotta be 1. Yeah, it's gotta be, yeah, because it's definitely taller than we are. And then how about the upright? About
For crossbar, she got 2.
Yeah,
2 feet for the crossbar?
I got 1.57 and then 10.74.
I don't know.
Oh, do you take your height into account? Yeah, add your height. Yeah, add your height.
Oh,
Guys, add your height for number 3, please. That's what you
I
guys
can't
are.
check if I did mine wrong. It's at home.
You turn later, or when you get home, just take a picture of the school.
I already turned it in, but I just can't check if I
Oh,
did it right.
okay. Got it. I understand.
I lost my worksheet.
I can check later. So, actually, you want to check for you right now? I'll hide it. Okay, I'll hide it. All right, hold on. I'll let you know. See.
I got 7.7
I got 90.
for the crossbar one.
That makes a little more sense. Yeah, because it should be a little taller than us, right? 90, that's crazy.
6.74.
That sounds a little more reasonable. Yeah.
That-
I think so. Yeah, I mean, you don't have to be spot on. It's just you want to, ballpark a little bit. I mean, we're doing measurements, right? So, let's see here. That's homework 28.
For like the upright one, I got 13 point.
Okay.
Does it look right?
Um, yeah, only thing is that for the first question, yeah, the flagpole, yeah, you're about right. Yeah, yeah.
Thank you.
Yeah, I think so. I think you're fine. Okay. All right. So let's guys move on to a lesson then. Perfect. Here we go. Okay, I might need someone to help me read because my voice is a little shot now. Yeah. Feel a little cough here. Okay, so we did the painting on the side of the house here, and it was a pretty involved problem. So we'll skip on to 538 and do 536 just to wrap this up. Then we have to do 521, which is also pretty long. So we got a lot to do. So we're starting now. Okay, and just as usual, I always print extra copies. Everyone's missing a note. Everyone's got the notes here. Good. Awesome. Okay, good.
Take my whole binder.
Oh, look at that.
And I
Like
put
it.
a folder at my house.
It's color-coded dividers. That's awesome. That's good. All right. Okay. So let's talk about 538, Nathan. Let's see here. Will, can you read about Nathan, please? 538.
I think this on mine.
538?
Oh, maybe.
Try after 539. Yeah, there we go. It's right there. Yeah, you're good. You're good. All right. So yeah, can you read one, please? Yeah, thank you.
At 11 a.m., pictures angle climbing up the wall. From the angle like up to it's about 10 degrees.
Okay, L cup sounds big deal. That's kind of crazy to scale that without any ropes. So he's standing in the meadow, 185 feet from the base. 11 a.m. Okay. Angle sight's about 10. Okay. If Nathan's eye is about 6 feet above the ground, how high is Emily at 11 a.m.? So for part A, I kind of draw it like this. Here's Nathan, little stick figure. And we'll say his friend is over here. There's a little right triangle. He's staying 185 feet away from the base of the mountain. And that's at 10 degrees. Now this distance is his height, which is 6 feet. This distance, I don't know. I'll call it X. And those two arrows should be touching each other, actually. So make it a little better. Okay. Does that make sense, the diagram? We're okay with the diagram, right? Okay. So we'll solve for X in a moment. Before I do that, what's part B asking us to do? Part B is asking us at 11:30 a.m. She's climbed some more. Now it's changed to 25 degrees. How far has she climbed in the past 30 minutes? So I'm going to draw it again. Beauty about Zoom is I can copy and paste, then move it. Oh, I thought I copy and pasted. Hold on. Copy, paste. What? Hold on. Oh, we gotta do that. There we go. What? Okay.
Oh.
It's being silly. Hold on. Never mind. I'll draw it again. So be it. That was being clever. So part B is going to look like this. And I'm going to have you guys do the calculations because that's what you guys should do. So our friend's higher now. We'll call this Y. That's still 6. And that's 25 degrees. And then finally for part C, I'll do it down here. Actually, I'll do it here. I need some barriers. Finally for part C, she climbs 32 feet higher in 10 more minutes at 11:40 a.m. At what angle will they have to look in order to see Emily? Okay. So let's see here. Do that. Little stick figure. And you want to, you got this. This side's going to be Y plus 32. From here to here, that's still going to be 6.
And then angle theta.
And theta, exactly correct.
How do you know that?
So that's like the variables.
All right. Okay, so what I did, try to be efficient here. Let's just get all the diagrams out of the way. Let's just understand the scenario, right? Okay, sees his friend, looks okay, great, 10 degrees, she's whatever. We gotta solve it. Then let's see, waits like 30 minutes. Oh, she's probably more. It has to look even higher to see her. We gotta figure that out. Finally, she climbed 32 more feet after the second situation. That's part B. So we have to figure out the angle that we have. So now we have to set up some equations. So draw, set up equations, solve. It's a 3-step process. So just so you know, 3-step process, guys. 3-step process. Draw. Write equation. Solve. So for part A, what's your equation going to be? What are you going to say for part B?
Tan 10 equals X over 185.
Yep. Tan 10 degrees equals X over 185. Okay, what's your equation for part B?
10.5 equals y over 1.
Perfect. And finally, for part C, what's your equation? Tan theta equals
Y plus 32.
over 185. And we'll figure out y is in a little bit. Okay. So far, so good? Okay.
You have to add $6.
Correct. Yes. We will need to add 6 afterwards, just so you know. Okay. I think all the finer details, you guys know, multiplied by 185, I don't need to show that. And we know you have to be in degree mode. So we do 185 times tan of 10. I get 32.62 feet. However, you have to add 6. Still a little dangerous because if you do fall, you could hurt yourself really badly, still kill yourself. So you gotta be careful. I know it sounds awful, but if you fall, Faith made it to school. Good. Thanks, Faith. All right. So yeah, we're okay with that. 30.62. Okay. Now if I do the next one, 185, tan, 25. Now she's deaf. Wow, she's quite the climber. 86.27. That's actually quite impressive to get that far in half hour. 86.27. Actually, I don't know if that's good. I don't climb, but seems good. And you have to add 6. So it's 92.27. However, let's stop and pause a little bit here. This is where why people don't like word problems. The only because they don't understand, they don't like because he has his points. That's what he has. We'll feel his points often. And that's because we don't read here. Okay. So yes, you set up, you did a beautiful diagram, you got Y, and of course we could add 6 with versus height. But what is the question really asking? It's not asking how high she's off the ground. Of course we know she's 92.27 feet off the ground. Of course we know that, right? Because that's why we solved for it, and you add 6 feet for the guy. Great, whatever. But what's it truly asking? How far she climbed in that 30-minute time frame from part A? So part A, her elevation was what? Off the ground. At part B, her elevation off the ground is 92.27. So what did she gain? Yes, good. What did she gain? I mean, not a big deal if you forgot to do that, but you wouldn't get the full credit, right? So I'm not going to box that. For part B, you got to do 92.27 minus 38.62. Now, I will say this, because there's a lot of rounding going on here, if you're off by like 0.01, 0.02, I'll be forgiving about that. But you got to make sure you subtract, because that's what we're trying to do. So that's going to be 59.65. So she climbed.
I got 53.65. Yeah.
I could have made a mistake. You know, I made a mistake. It is 53. Because I accidentally put 32 in. So see, I made a careless error too. Yeah, 53.65 feet. Cool. So that's part B. Fine for part C. Now we know what Y equals. But remember, you have to use Y, not 92.27. So that's what Y equals. So let me get rid of this stuff here because we already got that all figured out. Yep. So tan theta equals a 6.27 plus 32 over 185. So tan theta is going to equal some wacko number. A 6.27 plus 32 divided by 185. Some wacko decimal point, 639, whatever. It's going to be a little more precise by going out a few decimal places. Theta will be the inverse tan of that junk.
Do we have to find that decimal place? Or can we just like,
You can round at the end. Yeah, you can round at the end.
so we can just do, negative, or what's it called?
Inverse tan
Inverse tan.
of the fraction. Yeah, sure.
Okay.
Sure, yeah. You keep the fraction intact in the calculator, right? Actually, I recommend you do that.
Yeah, that's my too.
So
You
it's
should get 32.59 degrees.
To add 6.
No, because we're solving for an angle,
Okay.
not a physical height.
Oh, okay.
Yeah.
We should need a division more if you're doing the inverse.
No, inverse. So
Needed division.
we're not multiplying anything. That's why. So remember,
But I don't want to give it upside zero.
tangent, so tangent's not a variable, it's a function. and you want to move the tangent to the other side. To do it to the other side, go to the division symbol, because it's not much changing. It's an inverse.
Just felt like we were not possible.
Oh, I do. I, oh, sorry, I didn't understand your question. I thought you were saying this is a multiplication. You mean, these are being divided?
Yeah, but your hands and your small.
Oh, right here, yeah, so I already did the division already, like 16, 19, I already took care of it. Because when I put it in the calculator, it gave me this answer.
Oh, okay.
I took care of it initially, got it. I didn't understand your questions, so yes. Yeah, here.
So if you do like the inverse tan, do you have to show like a lot of work?
No,
So you could just do like that equation and then just
Yeah.
the answer, okay,
I mean, show the setup,
yeah,
so when I make the rubric for this, I'll have this like 5 vertical point. Like,
Mhm.
okay, you got the setup here, and another point to show that you're doing inverse tan, and another point for the actual answer.
Okay.
That's all almost, actually, the answer itself, I probably would make half a point for the number, half a point for the loops. So, but yeah, 32.59 degrees. By the way, if you got an answer that's less than 25 degrees for part C, that'd be weird, right? Because the angle should be higher. And if you got an angle that's way crazy, like a negative angle or angles more than 90 degrees, that'd be kind of weird too, right? So you want to make sure the answer seems physically reasonable. If it doesn't, it's probably because you made fails here. And don't lose faith, don't lose hope, don't lose confidence. Just yes, no pun intended. Even though we lost the thing, no. Anyhow, don't lose confidence. Probably make your mistake, right? But physically has to make sense. All I got.
So I did this. Beautiful. So can you check my work?
Sure, yeah.
It says that it's 53.6.
Yeah, it is 53.65.
Oh.
Yeah.
Oh, okay.
Yeah. I accidentally put 59. Correct. Okay, so that's a really good word problem. Like that problem a lot. It's
Something that would be on the test.
probably. I haven't thought about the test yet, but I'll give you guys details before we leave for break. 'Cause I do want to have it all kind of all figured out before break starts.
Wait. This test and then the final.
Right, and then some people have a retake in the middle, but I know that's not you, but yeah. And the final will be on the 16th of December. So our test is on December 4th, finals December 16th. So it's a pretty quick turnaround. Anything we cancel, anything's fair game. I mean, we will give you, okay, guys, for the final exam, just so you know, because for the freshmen, it's probably your first time doing like a real final exam week. For the sophomores, you could probably tell like final exam weeks can be really, really intense. Definitely compare, because middle schools don't do finals, right?
No.
So, which is okay, which is fine. But I will show you guys like a process to help you study. Like, hey, maybe you should start looking at your notes first. Look at like, I'll try to organize as much as I can. Like, here are the notes, or here's like video links that go through this. So actually have hyperlinks. I could do that for you guys. Like, okay, if I don't know this topic, like I'll make an outline essentially. Like, oh, here's an outline. And you want to kind of follow a process. Like, you don't want to just do practice problems. Yes, it's good to do practice problems. You need to do that, but you need to follow a process, like a method. So I'm gonna help you guys with that. So yeah, all good. Yeah, that'll be on that Monday. And if your A period happens to be social studies, then you only have one final on that Tuesday, right? Because you already took the other final on the, I don't know. If you have science as your A period and math,
That's what I have.
use that weekend to study hard. Yeah, get a head start. Get a head start. Yeah, because that's gonna be pretty intense. All right, okay, guys, let's move on to 56 now. Sorry, 536. Here, can you read 536, please?
David and Emily are climbing El Capitan
Guys, quiet, please. Thank you.
in Yosemite National Park. David is on the ground holding the rope attached to the carabiner
Yeah,
above
whatever.
Emily as she climbs. When Emily stops to rest, David wonders how high she has climbed. The rope is attached to his waist about 3 feet off the ground, and he has let out 48 feet of rope, which goes up the carabiner and then back down the wall to Emily's harness. The rope at David's waist makes a 55-degree angle with the ground, and he is standing 20 feet away from the base of the wall. Assuming that the rope is pulled tight, approximately how long is the rope between David and the carabiner above him?
Yeah, that's a lot of information there. Okay, so here we're gonna draw again. A lot of information.
A lot of people are climbing this mountain.
All right. Yes.
How like wait as she climbs, like I'm just confused.
I'm gonna draw it. So. Okay.
Drawing. Oh.
Okay, so he's standing 20 feet away from the base of the wall. Okay, I totally not do the scale, but that's okay. That's 55 degrees. And this is 3 feet right here. Okay. And
Wait, what, it's like 48.
I know exactly. Give me a sec here. Because you would think that this would be 48, right? But I don't know if that's true.
It's like.
Yeah, hold on a sec. So I'm gonna cheat a little bit because you're not supposed to see that. Hold on. Let's close that. We don't need that open. Don't need that open. Actually, man, I do need that open. Yeah, good question. Yeah, because I'm a little confused myself. Here we go.
That's smart. I don't know if I'm gonna get it all. Insane. I'm so mad at my dad.
Oh, okay. Okay, I got it. I see. Okay. Okay, here's the diagram. It's a little funky. Guys, quiet, please. Thank you. All right, in the rope. Rope point 48 minus 13 by 34. That's 20. Okay. All right. Here we go, guys. Okay, guys, we're back. Guys, it's not chips. Guys. Hey, we got stuff to do. Okay, I know, like I was off for like 2 minutes just to check what's going on, but doesn't mean you guys can talk, right? All right. So don't worry about this whole 48 feet. We'll worry about that in a moment. Let's just call this let's call this Y for now. Actually, we'll call it X. Call it X. Here we go. Okay, how would I solve for X? What would I do?
You would do.
What trig function?
Uh,
Yep, cosine. Yep, good. Cosine 55 degrees equals 20 over X. Okay, remember whenever the variable's in a denominator, that's a little funny. So I'll actually show you the steps so you guys are not lost. And then you get this. Yeah, does that make sense from algebraic perspective? I did multiply X 5 plus 5 and get the answer. Look, go ahead.
How much? Oh, sorry.
That's right. Collect to Maggie. No, yeah, collect your hands first. Good. Now Maggie. Okay. Not necessarily.
Can we just go straight to this?
So here's what you could do. Yeah. So yeah. So what Maggie asked. So there's 4 steps here. You have to show all 4 steps now. Step 1, step 4. That's good enough for me. Now, if you do have some sort of careless mistake, it might be hard for me to see that mistake, right? So I don't know how much prospect potentially it could give. But yeah. But obviously the setup here is worth a point. Is the answer is also probably worth some value, has some value too, right? So now, and sorry, I don't know why I put degrees. That was dumb. This is feet. My apologies. Okay, but here's the deal. He let out 40 feet of rope, right? I know it's kind of weird, but like, so he has 40 feet of rope kind of lying on the ground. Okay, so it's just like kind of just all over the ground, right? But then he ties it to some sort of, it's kind of like a pulley system in a way. That's what's happening. So what happens is that the rope is loose, but when she's climbing, she's going to start taking some rope, right? How much rope does she need to take?
34.
Right. So what you want to do is subtract that because they're saying how long is the rope between him and the carabiner. So basically, what it's asking is the carabiner is like this thing that's kind of like, so he's not really. So what's happening is there's like some sort of other location where the rope is tied to. And then of course, we have the no, exactly. So basically there's a lot of slack. Here's what it's asked for. How much slack is left over? That's what it's asking. Because when you have rope, right? The rope's not tight right now. You just have like the rope kind of laid on the ground. And then she starts pulling on the rope, right? Yes. So here's the other diagram. This diagram should help. It's a little tricky. So it's kind of hard to see. So this is, I guess, the carabiner. I don't know if that really.
I was just asking for that little piece.
Correct. So we just take the difference. Right. So it's right. Exactly. That's what you're doing. Correct. Yes. Actually, yeah. So we do know. So from here to here, right?
It's
Yeah. From here to the woman, it's 34.
Oh, okay.
And then the leftover part is tied to here.
But in all of it, it's 48.
Correct. Right.
So if, what are we trying to find? Like the
Okay. So
tiny little part?
yes, the tiny little part. Yes. That's what we got to take difference. Tiny little part right here.
Oh.
So yeah, let me do this. So we have this right here. I don't know. It's a little tricky. It's
bonus problem.
it's a little confusing, yeah. But anyway, hey, Will, dude, come on. All right. So 48 minus 34.87. So just take the difference. Essentially take the difference. I think the problem's trying to get too cute. So too cute. Like, oh, he's doing this, like they're trying to get too creative. I don't know. That's what I mean by cute. It's not cute. It's no. I'm just using that loosely. Okay, but how high the wall she climbed, that we could do pretty easily. We could just solve for y. And that should be pretty straightforward. That you guys have done many times. Tan 55 degrees is y over 20. Once you solve for y, they have to add 3, right? So 20 tan 55, get 28.56. But you got to add 3. That I'm not worried about. We've done that many times now, so I think you guys would be cool with part B. Part A was just kind of weird. But so apparently, so here's really what's happening. There's some sort of other structure here. Okay, so a structure here. So to answer your question, let's say calls like A, B, C, right? If I add AZ to BC, that's 48. AB, of course, I solved for, which was 34.87. This right here is what they're asking for. because you have to have some other structure to kind of like. Because it means you're creating a pulley system in a way, right?
Yeah.
That's how like this kind of, I don't fuck.
Is this how it's between like David and the Carib?
Yeah, so essentially it's confusing. They're asking for this distance, that's what they're asking for.
Okay, 'cause, like,
It's so confusing, I get it, just don't overthink it. And no, I'm not gonna ask on a test, I don't like it. Yeah, my word, I'm not gonna ask that. It's just too confusing. Okay, all right, so now let's move on to 5, 2, 1. Probably get about halfway through these notes. I think we could get halfway through, and that should be sufficient to do the homework. Oh, homework, by the way, is gonna be Delta Map. Mr. Davidson will actually assign it to you because he controls the Delta Map. So just go to your Delta Map. I'll get the link from him, but you guys should have access from the summer assignment. You guys should not have lost that access.
Is it like long like the other?
I don't know yet. He actually is better. I when I made a really long one. He tells me like, no, you gotta cut it down. Like he's a more reasonable man than I am. I'm crazy. So okay. Anyhow, so 5, 2, 1. So move on to the next part of the notes. So you want to kind of flip a few pages. I'll just read the beginning part and kind of have you guys do some work. Darren wants to find the side lengths of a triangle at the right. The only problem is that he left his calculator at home. Oh, okay. So does not remember the value of cosine 60. Okay. That's okay, says his teammate. I think I see a shortcut. Great. Using tracing paper, should create the diagram at the right, blah, 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 reflecting a triangle. Awesome. Okay. Okay. Ooh, this is interesting. Yes, of course. Yeah. Okay. This is interesting. Okay. So you guys know about tracing. We're not going to do tracing paper. You guys know about tracing paper, right? Like, yeah, you just reflect things. We've done that before. It's all good, right? So if you think about it, this new triangle that's dashed, isn't that the same exact triangle as the one that's in solid lines, right? These are two identical triangles, right? So if that's 60, what's this going to be? Yeah, 100%. Boy, yeah, good. 60 degrees. Okay, awesome. Now, also, if you think about it, let's figure out these two little guys right here. What's that going to be? And what's that going to be? So you got 60, you got 60, you got 90 and 90. What, go ahead. Together, both of these are 60,
30.
but individually they're, yeah, right, 30. Thank you all. Individually 30 also. No, I knew you were going to say it. I trust you. Okay. So, yeah. So what kind of triangle do I make? I make an equilateral triangle. Yeah, because what's happening, right, correct. Correct. And how do you know? 60 degrees. Right. All the angles, not sides, all the angles. So what I could do, I could also just say this whole thing here is 60 degrees as well. Okay. So what if Jan had reflected across a different side? Would result still be an equilateral triangle? No. It would look like this. It would look like that would have been 120 degrees. And each of these would have been 30 and 30. When I say reflected, guys, what if she reflected around the shorter leg instead of longer leg, right? It would look like, it would look like this. So it's better to reflect the bottom on the bigger leg, right? So you can make one thing. Yeah. So now, what do you think A equals? You don't need to do trig necessarily to do this. What do you think A equals, guys? Well, how long is this side? If you have an equilateral triangle. Let me get rid of these other things because it's a little confusing. So if it's equilateral, what does it mean about all the sides? A is 1, yes. Because that's 2, and that's 2. And so when you draw this, when you cut it in, when you draw the altitude, you're cutting in half, right? So you get 1 and 1. So A is gonna be 1. It's not an approximation, it's actually spot on 1. Yeah, without using, yeah, we don't need trig. Because A is half of the side. It's half the side. Okay. How are you gonna solve for B? Go, Colette.
1 times 1. Wait, like,
So what was that called? Pi fact, perfect. Yeah, but 1 times 1 squared, sure. Oh, were you doing the geometric mean? No, I don't know if that would work. No, that wouldn't work because that's when you have another right triangle, right angle with it. That's when you have something like this here. You have something like this, and you're cutting this and cutting that. That's a different situation. That's when you have another right. We have a right triangle. When the big triangle is right triangle, the big triangle is not a right triangle. Put it that way. So, guys, we're just doing Pythagorean theorem to do part D. Actually, I'll move down the screen. So, you guys okay with ABC? ABC, we're good. All right. So now let's move down to part C. Sorry, part DE. Let me erase some of the stuff here. I don't need all this stuff. Okay. So, yep, part D. Now solve for B. That's easy. 1 squared plus B squared equals 2 squared. B squared is 3. B is root 3. Yep.
B squared is 3.
You might.
4 minus 1.
Oh, you just
4 minus 1. Okay, now I could redraw it. Here's what I got. I got 1, 2, and root 3. And of course, that right there is 60 degrees. Okay. And it says apply zoom factor. Fine. Whatever. Let's do it. No, I don't want to do it. I'm just being very casual.
Why don't you do like √6 instead of 2 √3?
Okay, great question. The square root is an exponent. You anticipate order of operations. So, for example, what if I had 2 times root 4? It wouldn't be root 8, right? Because root 4 is 2, so 2 times 2 is 4. What you're doing is you're putting the 2 inside the radical. When you do 2 root 3, you don't want to do that because a square root's like an exponent. So we gotta respect order of operations. Be very careful about that.
4.
I'm tripling. So what's happening is that all the ratios stay the same. Are you okay?
Yeah.
All right. So what do you notice? The ratios stay the same. It's all proportional. Okay. So moving on to the next page. We come up to like this big aha moment. All right. So Darren's triangle is an example of a half equilateral triangle, also known as 30, 60, 90. This is a big deal. You will guaranteed, girls, guaranteed this will show up on the SAT. I'm almost certain of it. It shows up on every SAT exam, this kind of question. They give you the ratio, by the way. They do tell you the ratios for 30, 60, 90 triangles. But that's what we're going to look at. So he starts to understand Jan's shortcut, still has some concerns. Will this approach work on all triangles? No. SAT. Triangles that involve these angles. 30, 60, 90.
Like figure out like.
A missing side. And like there's like, but you have a calculator, you can always use trig if you want to. But yeah. And they have Desmos on the SAT as well. Yeah. Yeah. Okay. So guys, I got about 10 minutes. Thank you. Anyhow, So will this approach work on all triangles? No, you must have 60-degree angle. So you must have 60-degree angle. So let's take a look at part B. Well, if it's different size, that's okay. Because 30, 60, 90 triangles are all similar, right? Because all the angles are the same. All corresponding angles, right? So that's okay. It's not a problem. So here's what I know. This is 4, and that's 4√3. I was able to do that quickly because we know this is half of the hypotenuse. We saw it earlier, right? And we know this is this side times √3. Didn't we have like 2, 1, and √3? 3, and then we did what? 4, 2, and 2√3, and 6, 3, and 3√3. So great. 8, 4, and 4√3. There we go. So you never ever need to use trig for these kind of problems because you know the ratios will always be true. These ratios are provided on the SAT. For those who are sophomores that did the practice test, yeah, you probably may have seen that. Yeah, all good. Yeah, of course. Yeah. Thanks for asking. So yeah, that's what's going on there. So is a longer leg of a 3690 always going to be the length of the short leg by √3? Yes. And again, you must respect
What does that mean?
the ratio. The ratios never change. Actually, you know what? That is kind of confusing, actually. Must keep the same ratio. That's what I respect.
Is that also on our test?
The quiz. I believe a question like this might be on the quiz. Yeah. Yes. Oh, you missed it because you walked in late. Yes. We're doing quiz tomorrow. Yes. Well, I mentioned I was going to do it last week, but I just kept pushing it. But it's going to happen tomorrow. It's just a small. It's for me to see where you guys stand right now.
Is it gonna be like on a?
Major. I don't know. Let me talk to Davis. I don't think so.
It's
It could. It could.
It's not like the 30, 60, 90 triangle.
Okay, so guys, quiet. Let me. I got 7 minutes left or 6 minutes now. Okay. So what we saw, we drew an equilateral triangle, right? We saw just half of this. That's it. This is always half of this.
Yeah, but
And-
like,
and-
how about for part C?
Part C.
Like, what does that mean?
Oh no! All it means that you're just multiplying this by √3. X is a longer leg, right? And notice that X is Y times √3. That's it.
How did you know it's like?
Because we did Pythagorean theorem on the previous page, right? Didn't we do Pythag?
Applies to every single triangle?
Yeah, of course, because think about it. You have 8 squared minus 4 squared, right? Think about it. If you know this side and you know this side, you can do Pythagorean theorem to get this side. But what I'm telling you is you don't have to waste your time doing Pythagorean theorem because you always know it's going to have the same ratio.
But I'm just confused, how do you like know if there's 2 variables in the thing, like how can you do?
Okay, let's go back to the previous page. That's what we gotta do. Let's go. Yeah. So let's go back to the previous page. So what do we know right here? That was this will close the loop because I see we have to close the loop. So that, you guys, do you see why that's 1, right? Okay, and then you see why it's √3. Exactly, that's it. So now what happens that if you scale these up, right? So if you multiply this by 4, guess what happens to all the other sides? They also multiply by 4. So 4, 4, 4. That's why it's 4√3. That's why. So you what?
Then 5 root.
Correct. Yes. Yeah. So what you were missing was the proportional part. You were not seeing that yet. Now you see it.
Base this triangle because it's like has the 1, 2.
Correct. Right. Yeah. Man. Good.
For this
Mhm.
one, the number's 8. If the side is 8.
Yeah. So but remember, we're always going to take the shortest side is always half the hypotenuse. Okay. So guys, let's do this really fast. This will help. What if I drew a right equilateral triangle, right? How long is the side now? 4 and 8. And how do I solve for this side? I could do, but instead of doing it over and over again, you know it's going to have a √3 in it because we saw it from the smaller one, right? Because when we did the smaller one was like this, right? That was 2 That was 1, 1, and 2.
You know, like you split the triangle, like.
And that was root 3. No, they're all the same length. We talked about it. No, that's 8, 8, 8. They're all the same. It's equilateral still. What do you mean? What's different?
That one adds up to 2.
Oh, no, that's at the 8s.
I know, I mean, on the other one, those add up to 2 and the side equals 2.
Yeah, 2, 2, and then
Oh, no.
it's all proportional. It doesn't matter. All right, guys, let's keep moving because I do have to keep. Colette, can you hold your quick? Because I got to finish this. Thanks. Yeah, if you don't mind. Okay, let's look at D and E, and then I'll feel better once we finish this problem. Then I'll get to your question, Colette, at the end. Okay, so for D. All right, so yeah, so now I know what's happening. I know that M is going to be double. Actually, let's just do this, guys. I think this will help you guys. Let's just draw this. Here we go. Okay. This should help you guys. So what's that going to be? Good. So by drawing another triangle, right? So I think I'll help you guys. Notice I extended, not extended, but I drew another side and then drew another side there, right? So if I deliberately draw such a way where this is identical to this, right? I just drew an identical triangle. That has to be 15. That has to be M. So how long is this side here? Excuse me, 30. So M has to be 30. Yep. M is 30. No. Now you know the ratio. Guys, what the height is always. What do we notice about the height every time? Yes. So what number are you going to put in front of root 3 for n? What times root 3? Nope. Guys, what's my sign here?
15 root 3.
15 root 3. Because remember we scaled up by 15, right?
Oh, like the number of that, of the bottom.
Okay, why we're doing root 3? Because remember we had this earlier, right? And I totally get you guys are a little bit stuck. I totally get it because it's newer topics. Okay, so do you see why that's root 3? The dash one. 1 squared. Remember we did Pythagorean theorem. 4 minus 1 was 3. That's root 3. All I did was I just scaled it up. Guys, all I'm doing is just scaling up. There's no magic to it. I'm just scaling up. That's all I'm doing. No, guys. E. Will, stop talking. What's going on, dude? Stop it. Like it's like 5 times I already had to warn you. And you too, Lucas. Both you guys. You guys are staying apart next class.
I do.
You got because you're talking to them. You're distracting them and each other. Anyway, I got like 40 seconds left. Last thing here, Darren drew this triangle to the right, 36 and 9. What do you think? It's not going to work. So this is not okay because 3 is not half a 7. So this would be something else. We'd have to use trig to work it out. So anyway, not half a 7. So anyhow, that's what's going on there. All right, I'm done. Homework will be Delta Math. So just check, schooled you for that. And we're all set. I'll see you guys later.
Yeah.
You're welcome. Yeah, of course. Yeah.